Hi everyone, welcome back to my number sense series. In this video, we're going to talk about the most important theorem in all of geometry. Super famous, the Pythagorean theorem. Now, I'm sure some of you know the statement of the Pythagorean theorem already, and some of you don't. So let me show you first. The Pythagorean theorem relates the side lengths of a right triangle. So, given a triangle with legs A and B and hypotenuse C, the Pythagorean theorem simply states that a squared plus b squared equals c squared. A very, very simple statement, and a statement that some people see as the face of geometry, or maybe even mathematics in general. And I don't fault them, because the Pythagorean theorem is so important. So with the Pythagorean theorem, we often search for nice right triangles. So most right triangles, if you look for random leg length combinations, for example, 4 and 7, this is nothing nice. The square root of 65, not good. But there are some very famous triangles that have integer, whole number side lengths, and those are called Pythagorean triples. So the most famous one is 3, 4, and 5. So you have 3, 4, 5, and you can verify that this is a real right triangle by simply performing 3 squared plus 4 squared. What's that? That's 9 plus 16 equals 25 equals 5 squared. That checks out. Now, another one of our famous triplets is going to be 5, 12, 13. This is another very famous one. 5 squared plus 12 squared equals 13 squared. Another one would be 8, 15, 17. 8 squared plus 15 squared equals 17 squared. And I would say these are the main three that you would need to know. There are some other ones. For example, maybe 7, 24, 25. This one's pretty common as well. Maybe 9, 40, 41. Maybe even another one that is lying in wait somewhere over here. But these are the three main ones. This one's also pretty common. So I would maybe even say 4 main Pythagorean triples that you should definitely know, try to commit them to memory. And then there are going to be some other ones that number sense is trying to use to trip you up with. But if you are familiar with the Pythagorean theorem, it shouldn't be an issue. Now, one final thing, or two final things that I want to talk about. One of them is scaling. So with a Pythagorean triple, we are not limited to just 3, 4, 5. Because if you just imagine 3, 4, 5, if you just imagine making the triangle bigger, okay? Imagine expanding it like a balloon, keeping it like the same, but just kind of maybe zooming out on it or zooming in. Depending on how you think about it, we can turn this 3, 4, 5 into a different triangle, where the side lengths are in the same ratio, but they are different numbers. For example, if we double every side length, it becomes 6, 8, and 10, and this is still a valid Pythagorean triple. In fact, we can multiply the side length of a Pythagorean triple by any number at all, and it's still going to be a valid Pythagorean triple. For example, 6, 8, 10 is 1. If we multiply it all by 3, we get 9, 12, 15. That's also a valid right triangle. If we divide it by 2, we would get 1.5, 2, and 2.5. That's also a valid Pythagorean triple. So just understand that if you want, you can scale this triangle up or scale these triangles down by any amount, and they will still be valid right triangles. Now, one more thing that I want to talk about that is a little bit related to the Pythagorean theorem is how to find one other critical side length. We know A, B, and C, but there's one side length that number sense may also test you on, and that would be this side length, H. H is one of the heights of a right triangle. If you think of this side as the base, then A is the height. If you think of this as the base, then B is the height. But if you think of C as the base, then H is the height. This perpendicular line from this vertex down to the hypotenuse. This is H. And we have a way to solve for H, actually, because, well, I'm going to explain it right now, but you don't have to necessarily understand it, but I will explain it. We have a technique to find the side length of H, and it is by calculating the area of the triangle in two different ways. Because the area of a triangle is, it's a property of the triangle, right? So if we don't change the triangle, we just change our method of calculating it, the area will still be the same because we're still finding the area of the triangle. We can just express it differently. For example, we know that the area of a triangle is base times height over 2. So for example, if we think of a B as height, B as base, and A as height, then the area of this triangle is AB over 2. A times B over 2. But if we think of C as the base and H as the height, that's also CH over 2. We can cancel out the over 2's and divide both sides by C to get H equals AB over C. And this is the formula that you should remember for H. H equals A times B over C. That is how we find H. So with that out of the way, let's do some problems. The hypotenuse of a right triangle with legs of length 14 and 48 is something. Now once again, this is not something, you technically can. If you really want to, you can actually just plug this into the Pythagorean theorem. We can do a squared plus b squared equals c squared, and you can, actually using number sense tricks, 196 plus 2,304, you could get that the side length, the hypotenuse, is 50. If you would like to use some number sense tricks. But that is not the intended way to do this. You can, but I do not recommend it. Because the intended way of doing this is noticing something. Noticing the ratio between these side lengths. And this is the critical thing with almost all of these problems. The critical thing is noticing ratios, because number sense would like to trick you with, into thinking that you have new right triangles that you've never seen before, when in fact they are actually just scaled up versions of the ones we already know. For example, notice this, 14 and 48. Well, both of these numbers are divisible by 2. So actually their ratio would be 7 to 24. The legs are 7 and 24. Wait, that's just a 7, 24, 25 triangle, right? Just scaled up by a factor of 2. So if we think of it like this, it's just a 7, 24, 25 triangle scaled up. So the hypotenuse will also just be scaled up by a factor of 2. If the hypotenuse was originally 25, then when we scale it up by a factor of 2, it should be 50. And that is how you should be doing these problems. Do not compute unless it is necessary. Sometimes it may be necessary, but generally it won't be. Now similarly, this will apply to our next problem. The perimeter of a right triangle with legs of length 15 and 20 is, okay. So they want you to find the perimeter, but really the perimeter is the sum of all 3 side lengths, and you already have 2 of the side lengths. So what they're really asking you is, what's the hypotenuse? Just like in this question. And just like in this question, this is a scaled up version. Once again, notice the ratios between these. The most important thing, look for ratios. These 2 numbers are both divisible by 5. So if we divide them both by 5, we get 3 and 4. Wait, the legs are 3 and 4. That's just a 3, 4, 5 right triangle, the most famous one. So if you multiply this by 5, you multiply this by 5, then you also have got to multiply the 5 by 5. So this would give you 3, 4, 5 times 5 is 25. But don't write 25 because it wants you to find the perimeter. Once again, always make sure you have what the question is asking you to find. Here they want us to find the perimeter. So the perimeter is 15 plus 20 plus 25 equals 60. That is the answer for this problem. Now our next problem, the area of a right triangle with leg 15 and hypotenuse 25. Wait a second. Now they give you the leg and one hypotenuse. They want you to solve for the other leg, right? Because to find the area of a right triangle, you need to know base and height. And often when we find the area, not always, but often when we find the area, it's going to be the 2 legs multiplied together over 2. We don't have the other leg, so we might think to use the Pythagorean theorem to solve for this. 1 leg squared plus the other leg squared equals hypotenuse squared, 15 squared plus b squared equals 25 squared. Once again, we don't have to do this. We can do this, and we would get b equals 20, but we don't have to do this, because once again, this is a scaled up version. In fact, these are the same triangle, but don't bank on it. These are the same triangle though. Once again, notice the ratios of the lengths. We have 15 and 25. These are both divisible by 5, so they are in a ratio of 3 to 5. Think about it. 1 leg 3, hypotenuse 5. That is just a 3, 4, 5 right triangle. And so, of course, we have the 3, we have the 5, we're missing the 4. We scale the 4 up by a factor of 5. We're going to get that we have a leg of length 20. But don't lose track of the goal. The goal is to find the area. And so the area is when you take 2 legs and you multiply them together and you divide by 2, AB over 2. So it'd be 15 times 20 divided by 2 equals 150. And that is our answer. Now, our final question is maybe a question that is not super nice. The perimeter of a triangle with legs of length 20 and 21. So once again, they say perimeter, but what you really have to find, the most crucial thing is the hypotenuse. And here, we may have to use the Pythagorean theorem. Because if you look 20 and 21, they don't share any common divisors. The ratio of 20 to 21 is literally just 20 and 21. So we really do have to use the Pythagorean theorem here. Unless you have this memorized. You might have this memorized, but most people would have to use the Pythagorean theorem. So let's do it. A squared plus b squared equals c squared. The legs are a and b, so 20 and 21. So 20 squared plus 21 squared equals c squared. Now hopefully you have your squares memorized. Absolutely memorize your squares. If you don't have them memorized, this would be 400 plus 441 equals c squared. So c squared equals 841. And now, once again, if you have your squares memorized, this comes in handy a lot, because then we can get that c equals 29. And this is another Pythagorean triple, 20, 21, and 29. But most people don't bother memorizing this, and in fact, I myself have not memorized this. It just kind of appears in my brain, instinct maybe. But if you would like to, you can actually memorize this. It's a bit of a niche Pythagorean triple, but it still shows up sometimes, like it did here. So final step, don't lose track of what the question is asking. The perimeter of a triangle with the legs of length 20 and 21 is 20 plus 21 plus 29. Final thing, if you remember our addition tricks, always add these two first. 21 plus 29 would be 50. 50 plus 20 is 70. And that is right triangles, the Pythagorean theorem. So in this video, we just learned the Pythagorean theorem, and more than that, we learned two very important things. One of them, the most important thing, triangles can be scaled up. Always, when you're giving these questions, don't jump straight to using the Pythagorean theorem. If possible, look for any hint that these are numbers that have been scaled up. 14 and 48, 15 and 25, 15 and 20. These are all numbers that share a common divisor. So if you look at the ratio will be smaller. And most of the time, that ratio is going to be a Pythagorean triple. So remember this. I hope this was really helpful to you guys. And yeah, that's going to be it for today. Thank you guys so much for watching, and I'll see you next time.